Similar to when we made changes to reactions and then needed to look at the change in their equilibrium constant, sometimes we make changes to reactions and need to look at the resulting deltaH of reaction. So deltaH reaction is always for that reaction as it's written. So, and we will have the exact same things. We'll have, if you do this to the reaction, this is what you do to the deltaH. If a chemical reaction is multiplied by a factor, the new deltaH reaction is multiplied by the same factor. And I will give you an example. So if reaction A is C plus 2D turning into E, and it has a deltaH reaction A value, and reaction B is 2C plus 4D turning into 2E. So it's the original reaction multiplied by 2. The deltaH reaction for reaction B is 2 times the deltaH reaction for reaction A. All right, second rule. If a reaction is reversed, deltaH changes sign. And we've seen this with phase changes already. So the magnitude is the same, but if it was previously exothermic, when you go in the opposite direction, now it's endothermic, and vice versa. So again, with the examples, if reaction A is C plus 2D going to E, and this has some deltaH reaction A value, and reaction B is E turning into C plus 2D. The deltaH reaction for reaction B is equal to the opposite of deltaH reaction for reaction A. And then the third rule, which has a specific name, but we're going to talk about the rule first. If a chemical reaction can be expressed as a series of steps, then the deltaH reaction overall is the sum of deltaH for each step. And this is known as Hess's law. So when we talk about Hess's law, we're specifically talking about the fact that you can add these reactions together and then just add up their deltaH values and you will get deltaH for your new reaction. It works because deltaH is a state function, and it's really nice because we can get enthalpy values for reactions that we don't actually have to run in the lab. So if we can put together a combination of reactions that we know values for, then we can do this without having to run that specific reaction. So just so that we also have an example here, if our first reaction is A plus 2B going to C, and this is deltaH1, our second reaction is C going to D, with delta H2. So I guess I should label these 1, 2. Reaction 3 is A plus 2B going to D. Delta H3 is equal to delta H1 plus delta H2. Now, what the problems that we do for this look like is that it will give us a resulting reaction. So it will give us, say, delta H3. It will give us some other stuff, and it will say, we know these. If we know these, calculate delta H for reaction 3. So you may need to do some of the earlier manipulations in order to get reactions 1 and 2 to look like what they need to look like to get into a form where you can add them together. And we will see examples of this in class.